Hello, my name is Doja Bassin, and today we're going to be talking about how electric waste and its consequences, about how it's bad for the environment, about how we can solve the amount of electric waste, and how it's just going to be better for the world in general. But first, before we do anything, we gotta first understand how many waste is happening. If you see this graph over here by the good old the Global E-Waste Mon 2024, basically the UN's site on how much waste is happening, how many people just dump electric wastes. As you can tell, like, the total waste, we got 17.6 kilograms in Europe, 16.1, 14.1, 6.4. You combine them all up, you get a bunch of kilograms worth of trash. And in American, that equals 63.3 tons, metric tons of waste that is just generated each year. And it seems to have only been rising. But first, we must ask the simple question. But Dad, what's wrong if we just dump a bunch of electronic waste into either the oceans or some landfills? Well, Timmy, I'm glad you asked. Now, enough about this friendly family exchange. Let's go to the next part, okay? Imagine you drop a particle accelerator inside of a landfill, okay? That's pretty bad. You know why? Probably because there's a bunch of elements and radiation and stuff like that happens whenever you drop particle accelerator. Now, here's a small problem. This disposing of particle accelerator is very regulated for obvious reasons. Which is why you don't see particle accelerators inside landfills. But you know what you do see, though? Yeah, I bet you notice all of these, though. As you can see from this beautiful pie chart that I made from a website, okay? 34% of the waste comes from small equipment. What small equipment, you might ask? Well, don't worry. That's why I'm doing this presentation, so you'd know what it is. Are kettles, vacuums, microwaves. Okay, these are like these are like some of the common appliances and more. Anything else that, you'd see inside of small equipment. Vacuum cleaners also count. And to simply put, what are the toxic effects of small equipment, you may ask? Well, plastics, right? You know why plastics are bad? I know why plastics are bad. I think we all know why plastics are bad. You know, microplastics being able to dissolve, how plastic takes forever for it to actually dissolve into the earth, There's some of, like, the minor things that small equipment have. And 26% of it, even though it says 25.5%, is large equipment. What are the large equipment? Well, this includes dryers, dishwashers, washing machines. As you see these two over here. Here's the problem with large equipment electronic waste, right? They take up a lot of space. And one of the biggest problems with electronics is that they require a lot of minerals, earth, and materials, right? And let me just tell you, mining isn't good for the environment. Digging inside of the Earth's crust to find some pretty good minerals when we could be just harvesting some of the minerals from these, I'd argue would be a little better, just a little better for the environment, okay? It looks like this has some steel inside of it. Maybe take some of the steel. Now, as you might see here, I didn't mention refrigerators part of the large equipment. This is because they label them as temperature exchange equipment. What does that mean? It basically means that it's, electronics that can regulate their temperature. And you know what's dangerous about temperature exchange equipment? One, they take a lot of space, and two, they have this thing called coolant. And funny thing about coolant, once it leaks and all the gases come out, or it becomes a gas or whatever, the amount of effect of global warming it has is a year's worth of driving with a car. That is how much, even though it's not carbon, it is like way more dangerous for the atmosphere and for the environment instead. And just a little bit of that gas, even leaking from like one of these fridges, is just a year's worth of driving of carbon emissions that you're doing to the atmosphere. Not good. And you know what another thing about this? You see this? You see the freaking refrigerator right here? You know what we could have done with it? We probably could have melted down to use steel instead of spending all of our time trying to mine the earth. For some minerals, we could have just recycled from this, okay? This thing called reusing what we have. And then comes screens and monitors. This includes TVs, tablets, well, you name it, okay? Whatever just has a big screen for you to enjoy and watch, okay? And this specifically, okay? This one we're gonna go into, okay? This is a special type of TV that ye old days that your grandparents used to watch. And basically, they're just the triple threat combo, okay? Not only do you have to release lead, okay? Lead is pretty toxic, as you can tell, and we're just letting that sit inside of our landfills. It releases glass, which, as you know. Now, to be fair, okay, most monitors, don't really use glass, okay? Unless you got like a very fancy monitor, which uses like Gorilla Glass or whatever. That's more dangerous, okay? There's some materials infused with that glass that, is very hard to mine the earth from. It's called rare earth materials. And finally, there's also mercury. Mercury is very dangerous, okay? Okay, ask the Chinese emperor what happened when he drank his bottle of elixir of mercury and, not good things happen. If you don't know what mercury is, you have, like, very small doses of mercury, and it does, like, a bunch of effects on the skin. Like, even breathing in, like, a light bulb fume of mercury can cause some brain damage, okay? Mercury is, like, very dangerous to humans in small amounts, and we're just, you know, imagine what happens if that adds up to a landfill. Okay, you don't want that. Okay, screen and monitors are just more general, and it really depends. However, there is a certain type of monitor, a certain type of display that is much more dangerous for our landfills. Now we talk about these boys, CRTs, cathode ray tube displays. Now, if you don't know what they are, they just shoot like a freaking laser beam that goes left to right, like, ooh. And basically, they do that by using like a vacuum chamber so the laser like perfectly hits all of the beams into the metal shell. Now, there's a slight issue with said laser beam, right? Okay, I want you to think of this, okay? This glass right here. This glass is infused with lead to keep it sturdy and strong. The glass has to be strong or else like the atmosphere around it will just crush the TV into half. And you want to know how much lead is inside of these types of glass? Enough to contaminate groundwater if it ever gets into the water supply. Now, if that's enough to cause, like, you know, a bunch of, like, sick people from drinking lead, then can you imagine trying to dispose one of these things over here? This right here, right? You can imagine, and as you know, the bigger the TV is, the thicker the glass has to be to keep it, you know, strong, to make sure it doesn't crush on its own weight from the atmosphere. Which, you know, in turn, people who just, you know, while they're not being made anymore, like, there's probably a bunch lying around in homes that people are just throwing out. And now finally, while technically small IT is like the second smallest on the chart, we also have lanterns, which apparently people throw away so many lanterns to the point where it's just 1% of the graph itself. So they had to make it its own, like, part in the pie chart in its own percentage. However, the second tiniest thing, small IT, this is the real one, okay? Even though it's like the second smallest on the graph, it's probably the one that's the most impactful because let me explain it like this. Well, let's first talk about what small IT is. Small IT is, as you see here, laptops, routers, phones, you know, small little electronic devices you use. And to explain why small IT items are so, you know, so wasteful and why they affect more than like, and why they affect the most is, let me give you a little demonstration, okay? Imagine that you have two options, okay? You have side A or side B. Okay, let's do a little game show, okay? Let's ask the question of, okay, how much does it take to make a 4-gram ring? About like a gold ring that you do for a wedding. Okay, guess how much gold ore it takes, and then guess how many phones it takes to make it. Okay, you have 5 seconds. Canceling the timer. This guy would win. This guy over here to the right would win. It's because it would take approximately 130 iPhones, okay, only 130 iPhones, to get enough gold to make a wedding ring, a ring band. That is how much it takes to get 4 grams of gold. Do you know how much the guy on the left has to mine? He has to mine 2 tons worth of gold ore. Just to make enough for a gold ring. So the question is, and we have about millions of like these types of phones inside of landmines that we could have just been harvesting for gold. And there's rare minerals too. There's also cobalt, which we're currently in a shortage of. We could have been reclaiming the gold by like, you know, just recycling iPhones or just phones and then just taking all like the minerals from them to make new stuff. That's all we could be doing. So you're telling me the entire time we could have been just recycling all that e-waste just so we could have more minerals? No. Now disappear. Now let's talk about a very important thing. The right to repair. So basically what the right of repair is that it's a movement where both legally and socially things should be easier to repair. And I'm going to put a video inside of the PowerPoint on explaining why that is. Okay, I think it's better to show you than it is to just explain it. And here's me editing the video as I speak. And here's what I want to show inside. So, as you can see, this desktop, you can replace anything you want, right? Let's say my laptop is just a little slow. I'm sorry. My desktop is a little slow. You can just change the RAM switch right here. I just take out those sticks and then flip them back in. Let's say my game of Half-Life is running a little slow. You just open the GPU, you replace a new one in, and yeah, there we go. Now, let's say that, like, the entire system, like, it takes forever for it to transfer files, for it to load. What I can do is that I can just, watch this. Open this here, right? Because it's just clickers. And then there we go. As you can see here, I'm sorry, the camera's not focusing, it's not turning on. As you can see here, we can just replace the SSDs and make it so, you know, to make it so it loads faster. And the reason why I'm telling you all this, let me just close this a bit, is imagine that if everything inside of this was all glued down, okay? You know what that would basically mean? It would mean that every time I want to upgrade, let's say I get into video editing, or if I get into, let's say, anything, I'd have to replace the entire desktop. And I just want you to think about, like, how this applies to phones, how it applies to laptops or any electronics. For example, it can be like something as simple as like, oh, the motherboard stopped working because like this one piece of like this 50-cent piece isn't working well. And you just throw this entire thing away, causing a bunch of waste. And another benefit of modularity is that because it is modular, as I said, it's easier for people to recycle. Let's say, like I said, if everything was just glued down to the point, everything was just stuck inside of there, like imagine how much work it takes, how much labor, how many resources it takes just to open the thing in the first place, just so you can get the minerals from it, right? And it adds up. Like taking one, you'd have to be very delicate. You have to basically use like a glorified heat blower or something just to open this. And I want to give an actual example. So actually, this laptop right here I had, right? Its battery actually was close to just straight up dying, right? It's just what happened was there's a failure, and let me show you an example. I have another laptop. Imagine it like this, okay? Let me show you the insides. Like, look at this inside here, okay? Imagine this thing is the battery, the entire thing. And basically the battery cells just completely just stopped working, okay? Meaning that this laptop can only run for like an hour before it would die, which is not good whenever you're trying to do college work, which you'd be there for like 4 or 5 hours. Imagine if I had to just throw away all of this, okay? All of the components, all the resources. We lose the CPU, we do this. And even if you recycle it, it would be hard if everything was glued down. But luckily, I was able to just like extend this laptop's life. $1,000, by the way. Imagine having to spend another $1,000 for a new laptop. I instead spent $100 just to replace the battery here. Okay, imagine it, but it's for this laptop right here. And basically, I've just prolonged this machine's life by another 3 to 5 years. And I just whenever it comes to any electronics, right? Okay, sometimes it is the smallest things that causes these things to go into the waste in the first place. So having things that are easy to repair to begin with will, one, make recycling easier, and two, will make it so that it's just people will use it more and it'll last as long, so companies will make less new things. And yeah, that's basically all I wanted to say about like how right to repair would help with all of that, about how to solve the waste problem. One, making everything inside of modern, like small things like phones or laptop, cause it to be just bigger. And to answer your question, kind of, not really. I mean, if you really think that like 2 credit cards worth of thickness is a price too high to make everything modular for the environment, then like, sure, I guess it makes it bigger. And actually, recently, the EU, right, California and some states have brought a bunch of right to repair laws, right? EU specifically making the law about how parts have to be standardized and how you have to have the part available for the next 6 years. And they also added a little repair score. I don't know if you've ever seen this in other countries, but like, depending on what you buy, there's an Energy Star rating on how much energy it consumes. It's that, but for repair scores. And this, in turn, are making companies kind of like fight on who has the most repairable product. And this March, right, because of those laws, this is actually a pretty good year for like right to repair, where Lenovo made one of the most repairable laptops we've probably ever seen in a long time now, other than like a framework. And Lenovo, as you know, is a major company. And basically, as you can see here, you can replace everything. The keyboard, you accidentally spilled milk on your keyboard. You can replace the keyboard now. You want more speed for your SSD. You decide you pick up video editing. You can replace that now. And they made it easy. You just need a screwdriver to open these things, making everything modular. The framework laptop, which was like the first like fully repairable modular laptop, has also been released, right? And it's also, yeah, even Apple is starting to try it, even though Apple is like the antithesis of right to repair. They just hate any kind of repairing. They like to solder everything. Even they decide to make their stuff a little repairable. And even Samsung themselves are making it so you can actually remove the battery and replace a new one. As you can see here from this iFixit image, if I move it over there, you can see that like it's now possible to repair with just a couple of tools, right? You just need some tweezers, you need some pliers, a suction cup to get the glass out. It's never been more affordable. Well, quote unquote affordable. You're still paying $1,000 for a phone. Well, come on. But the thing is, it'll last longer. Now, right now, it is a little more expensive because it is in its early adopter phase. But right now, it looks like a bright future for Right to Repair. And finally, the best thing about Right to Repair is that there will be less kettles in the trash. Remember that 34% about it and how much of the kettle is? Well, let me tell you a little bit of a guy I found, okay? Alright, let me just hit you with this. The repairable kettle. Basically, you know how like kettles are like part of 34% of waste? You wanna know a very simple way we could have done just to make it so people waste less kettles. And this was made by a genius UK student who figured it out, which is simply, what if you made it so you can open the bottom and just replace a new heating element in? It sounds like a simple solution, but really, that's all we kind of have to do. It doesn't have to be the grandest solutions just so we can make things repairable again. Like, it just takes some simple things just to make it so that, you know, they can last longer and we use less resources in general. Okay, it doesn't have to be like an overhaul design or a cultural uplift or anything like that. Sometimes it's just the simple things that just make the biggest change. And that's all I wanted to leave off with. Here are all of the sources used. Okay, bye.